Hi guys, today we are going to focus on one thing and one thing only. We are going to be working on how to find the determinant of a matrix. We will then use today's talk to introduce our final way to solve systems of linear equations. So with that being said, let's do this. What is a determinant? A determinant is just a real number. Okay, it's just a real number that's associated with a square matrix. The notation, we put a det and then A is the matrix, or we can enclose A in the vertical bars, which can easily be confused with absolute value of A, but no, that's actually the notation for determinant. So no matter how you write it, both are read as determinant of A. Cool. So now the question is, how do we define the determinant of a matrix? For the determinant of a 2 by 2 matrix, I guess you can memorize this formula, or I could break it down for you with an example. Okay, so let's just say we have some matrix. Elements are 1, 2, 3, 4. Yeah, I was very creative. And we are asked to find the determinant. Okay, so let me go ahead, write down determinant of A. I'm going to enclose the elements in the vertical bars. So to find the determinant of a square matrix of order 2, or in English, a determinant of a 2 by 2 matrix, we're pretty much going to take their cross products and subtract. Okay, so we're going to take this cross product from left to right. Product of 1 and 4 is 4, and subtract from it the other cross product, which is given by 3 times 2. Now, I know that you know that subtraction is not commutative, so we have to be careful in the order that we subtract, because if we had switched the order, if we had done 6 minus 4, then we would have gotten a different answer. So we always go from left to right. All right. I think I said that wrong, but you saw my arrow action, so let's do this. So like from top to bottom. Yeah, so and the difference of 4 and 6 is -2, so we want to tell the world the determinant of this matrix is -2. Fantastic. Now, how do we find the determinant of a 3 by 3 matrix? The determinant of a 3 by 3 matrix is not as straightforward as the determinant of a 2 by 2. The strategy that we're going to use to find the determinant of a 3 by 3 matrix is the same strategy that can be applied to the determinant of a matrix of order higher 3, so like a 4 by 4, 5 by 5, 6 by 6, so forth. Okay, so I brought in with me my little special effect, transparency, and a paper clip. That's all we need. Cool. So the determinant of a 3 by 3 matrix, if this is your matrix, then what will be the answer? This. Okay, this highlighted expression. I have no time to memorize this. I don't think it's even possible, so let's break it down. Now, when it comes to finding the determinant of a 3 by 3 matrix, let me go ahead, fix the light. Okay, that's making it worse. I should have just left it how it was. Okay, that's worse. Let me go ahead, pause this. Okay, so I'm not really a big fan of making these videos in a romantic setting, but when the light is in the way, then there's no choice. Okay, so where was I? To define the determinant of a 3 by 3 matrix, we're going to take any row or any column and expand it. Because this is an introduction to, I'm not going to get too creative. We're going to go ahead, expand the first row, and I'm going to highlight it for dramatic effect, just so you know which one am I going to expand. So we're going to take each element, and then we're going to multiply it by its minor, and I'll explain in a bit what that means. And then the question is, I noticed that in the answer we have minus or plus. How do I know if it's going to be minus or plus? Well, pretty much we always start with plus. So in the top left corner, that's always a plus. And then we alternate, you know, like tic-tac-toe, plus, minus, plus. And if we had a fourth element in that row, we will put minus. Okay, so now I'm gonna stop lifting that special effect. Okay, so what are we gonna do? If we expand the first row, we're gonna take that element, so that's A11, and multiply it by its minor. So pretty much that is the determinant formed when we cross out that row and column. Okay, so that will give us A11 multiplied by the determinant 4 by the element in this matrix, so A22, A23, and you can read the rest. Cool. So we have A11 times its minor. So determinant form by the leftover elements when you cross out the row and column. Cool. Yeah, I know my special effects, you like them. Hey, I gotta do what I gotta do. Okay, this eraser didn't work. It's a lie. So let me go ahead use, let's see, this sheet. Okay, I think it's my transparency. Okay, cool. All right, so one element down, one more to go. So I mean two more to go. So the next one is gonna be minus something. So we're gonna take minus A12 and then multiply it by its minor. So let me go ahead, circle it for dramatic effect. So that's gonna be the determinant form by the leftover elements when we cross out that row and column. So you can see, so it's gonna be this. So we have it right here. So we took the first element, multiplied by its minor, then we did minus the second element, multiplied by its minor. Now let's go ahead, take the third element and multiply it by its minor. So we pretty much take the absolute value of the leftover elements. So for the grand finale, we have plus the next entry, and then we're gonna multiply it by its minor. So it's the determinant form by the leftover entries when we cross out the row and column. So that will give us A21, and you can read the rest. Yeah, this didn't really go down how I wanted to, but I tried. So let's go ahead do some actual problems and get out of the subscript notation. Okay, so we are asked to find the determinant of each matrix. To be more specific, they're all named as A just to make it nice, and we are asked to answer without the use of a graphing calculator. And I make that clear because in a later problem we will be using a graphing calculator to just spit out the answer. Okay, so the determinant of a 2 by 2 matrix, so let me go ahead, write it out. The determinant of A, let's go ahead, use the notation for determinant. We have 8, -3 is the first row, followed by 4, 1 as the second row. Cool. All right, so with that being said, we're just gonna take the cross products. The first cross product is given by 8. So I'm running out of space, so let me just put determinant of A equals 8, and then we're gonna subtract from it the other cross product, which is given by -12. Fantastic. Last time I checked, difference of 8 and -12 will give us 20. So we want to tell the world the determinant of A, or the real number associated with this matrix, is given by 20. Fantastic. So now matrix B, problem B. So we have matrix A, and we want to find the determinant. So let me just go ahead, write it out. Okay, I have my special effect in the wrong place. Okay, so we have determinant of A equals, go ahead, use our vertical bars, and then we'll write down the elements. So we have 1, 2, 3, -4, 8, -6, and then -5, 7, and 9. Cool. All right, so my special effect is in the wrong place. I don't know if I should put a new one or not. Okay, that's okay, I won't. Okay, so I lied. I did bring out my special effect. Okay, so again, so we no longer have a 2 by 2 matrix. We have a 3 by 3 matrix. If we have a 3 by 3 matrix or any square matrix of a larger size, we're gonna do it the same way. We're gonna expand any row or any column and then take it from there. Because this is our first problem, we're just gonna expand the first row. Let me go ahead, highlight it. Sorry, wrong highlighter. And then for the remaining 2 problems, because we're going to do a total of 4, then we'll actually look at the numbers, which numbers catch our eye. In terms of the sign change, we always start with plus. So it's going to be plus, minus, plus. So when we expand, it's going to be plus 1 times whatever we have, minus 2 times whatever we have, plus 3 times whatever we had, and if we had a 4th element, minus this times whatever we have. So let's go ahead, write it out. So the determinant of A equals, okay, so let's go ahead, look at the first element. Okay, we already established that we have plus 1, so I guess I should begin to write that. And I'm going to go ahead, circle it, and then we're going to take that 1 and multiply it by the minor. So it pretty much is the determinant formed by the leftover elements when you cross out the row and the column. Okay, when we cross out the row and the column, as you can see, we're left with 8, -6, 7, 9. So we're going to be left with the 2 by 2 matrix. So that's nice, because to find the determinant of a 2 by 2 matrix, we just take cross product and subtract. All right, one element down, two more to go. Okay, so let me go ahead erase this. All right, so the next one up, we have -2. Let me go ahead circle it so I can highlight which element we're looking at, and then we're gonna multiply it by this minor. So it's pretty much the determinant form by the leftover elements when you cross out the row and column. Cool. So that will give us the 2 by 2 matrix given by -4, -6, -5, 9. Okay. So -4, -6, -5, 9, done. Okay, and then we're gonna be left with plus something. Yeah, my special effect is in the way. Okay, plus something. All right, so plus 3 multiplied by the determinant, the leftover elements when we cross. Oh, so let me circle the 3. Sorry. Okay, so what is the minor gonna look like? So we're gonna cross out the corresponding row and column, and that will give us the leftover elements. So it's gonna be -4, 8, -5, 7. Okay, -4, 8, -5, 7. Fantastic. So at this point, we have to focus on energy and finding the determinants of the leftover 2 by 2 matrices, and then continue the rest. Okay, so let me go ahead put this away because it's my only marker, so I need to take care of it. All right, so that will leave us with 1 times the determinant of this 2 by 2 matrix. So be careful with the computation. So first product is 72. And then we're going to subtract from it the other cross product. So remember, subtraction is not commutative, so be careful in the order which you take the cross product. So we start from the top and then we wrap it up from the bottom. Okay, so that'll be 72 minus the other cross product, which is -42. Fantastic. So one determinant down, two more to go. Minus the determinant of this 2 by 2 matrix. So first cross product is -36. And then we subtract from it the other cross product, which is given by 30, I believe. Plus 3 times the determinant of this 2 by 2 matrix. So first cross product is -28. And then we're going to subtract from it the other cross product, which is -40. Fantastic. So at this point, I feel like I can breathe. We totally got this. Let's go ahead, continue to take out our calculator. Difference of 72 and -42, if I punched it in right, gives us 114. Difference of -36 and 30 will give us -66. Difference of -28 and -40, let me go ahead and write it as addition. Okay, sum of -28 and 40 will give us 12. Let's do this. Okay, product of 1 and 114 will give us 114. Next product will give us 132, and final product will give us 36. And after all that hard work, that will give us determinant of A equals whatever that sum is. I'm not going to pretend like I did it in my head. I used the calculator. Fantastic. Something that I want to point out is this. So students had told me that they could take a shortcut. I forget the name, but I think it's called like a lattice or something. And then they, I'm not sure how it goes. They write down the first 2 columns and then they do some multiplication. It's pretty neat. Okay, but the reason why I don't stress that shortcut is because it only works for matrices of order 3 or 3 by 3 matrix. And I'm not a big fan of memorizing too many things. So remember, I memorize what I have to and understand as much as I can. The good thing about what we're doing right now about expanding a row or column works for any size matrix. Okay, you don't really have to worry about it. You don't have to worry about can I take a shortcut or not. So but yeah, so on a quiz or midterm, if you Google the shortcut way, you want to do it like that, that's fine. Just make sure you understand why things work. Okay guys, so we're gonna do a total of 4 problems. This was our second problem. Let's go ahead do the final 2. Just a sec. Okay, so let's go ahead and do the final 2 problems. for the final two problems, we want to find the determinant of these matrices, and then I need you to feel comfortable in terms of how to use your calculator to find the determinant. So I need you to confirm your result. Okay, so let's do this. So we have a 3 by 3 matrix, so it's a square matrix, so the determinant does exist. If we don't have a square matrix, then the determinant does not exist. Why not? Because the determinant is a real number associated with a square matrix only. So let's go ahead, prep this up. So we have the determinant of A equals, let's go ahead, use the notation. First row is given by the elements 4, negative 6, 3. Second row, negative 1, 4, 1. Third row, 5, negative 6, 3. Cool. So you can expand any row or column as desired. For the first problem, we expanded the first row because it's the first problem. Okay, we already have too much spice in our life. But this one, I want to see what numbers catch my eyes, or which ones scare me the least. Okay, so the first row is nice. I'm not a big fan because there's a negative in there. The second row is also nice. I really like it because we have ones in there, but I'm still afraid of the negative. The third row is nice, but I'm afraid of the negative. Let's look at the columns. We also have negatives. We also have negatives, and the numbers are a little bit spicier. But look at this third column, 3, 1, 3. The numbers are relatively small, and guess what? There's no negatives. So this column scares me the least. Okay, so we can expand any row or we can expand any column. So for the first problem, for the earlier problem, we expanded the first row, but now we're going to go ahead and expand the first column. So let me go ahead, highlight it. Now, in terms of the signs, they're going to be +3, -3. Again, we can do some really cool math, or we can just play tic-tac-toe. Okay, we always started with plus. So whether you go like write it across or go down, so it's plus, minus, plus. So I guess we're going to start off with +3, and then we do the sign change, minus, plus. Okay, so this is how it's going to go down. So we're going to have +3 times the determinant of the leftover entries, -1 times the determinant of the leftover entries, +3 times the determinant of the leftover entries, or in math we'll say times the corresponding remainder. Let me go ahead, prep it up with my special effects. Okay, so special effects are in full effect. Okay, so let's do this. So we have established that we're gonna expand the third column. Sorry about that. So we're gonna start off with +3. So we have the determinant of A equals +3 times the minor. Okay, so it's gonna be the determinant form by the leftover elements when we cross out the row and column. So it's gonna be the 2 by 2 matrix given by -1, 4, 5, -6. Okay, so we have -1, 4, 5, -6. Cool, fantastic. All right, so we're done with that element. Let's go to the next one. Okay, so the next element, it's gonna be -1. So -1 multiplied by the determinant formed by the leftover element. So in math, we'll say it's minor. So we're going to cross out the row and column. So we're going to cross out the row, we're going to cross out the column, and that will give us the following 2 by 2 matrix given by 4, -6, 5, -6. So we have 4, -6, 5, -6. Fantastic. Okay, second entry done. Cool. So now we have the final one, which will be +3. I should just use my hands. It will be a lot faster probably. Then we have +3. No, it's this mini eraser is nice. It's just I didn't give myself a lot of space. So +3. So let me go ahead, circle it, so that way you know which one I'm looking at. And we're going to take that +3 and multiply it by the determinant formed by the leftover elements when we cross out the corresponding row and column. Okay, so that will give us the 2 by 2 matrix given by 4, -6, -1, 4. Okay, fantastic. 4, -6, -1, 4. Awesome. So now at this point, let's go ahead, find the determinant of the remaining 2 by 2 matrices, and then we'll crunch it out. Okay, so first cross product. Okay, I'm not gonna cycle between two highlighters because it's not as easy as it looks. Okay, so that will give us 3, and the determinant of this 2 by 2 is going to be given by 6 minus the other cross product, 6 minus cross product, which is 20. Fantastic. Minus 1 times the determinant of this 2 by 2. First cross product is negative 24. And remember, we subtract the cross products. Other cross product will give us negative 30. Fantastic. Keep it going, so that'll be plus 3 times the determinant of this 2 by 2 matrix. First cross product is 16. Other cross product, give me a sec. Other cross product will be, what is that? I think that's 6. Yeah. Hopefully it's 6, because if not, I'm in big trouble. Okay, we did it. It's arithmetic. We got this. So we have 3 times, I believe that's negative 14 minus 1. Difference of negative 24 and negative 30 is out of my zone, but negative 24, 30 is in my zone. So that will give us 6. Plus 3 times difference of 16 and 6 will give us 10. We got this. First product will give us negative 42. Next product will give us 6. Final product gives us 30. Last time I checked, negative 42 minus 6 plus 30, when I punched it in, that gives us negative 18. So we want to tell the world the determinant of this bad boy, or the determinant of matrix A, gives us negative 18. Oh, problem B. So that one's pretty brutal, but is it going to be on the test? Of course it will be. Okay, so let's go ahead and do this. First of all, I want to confirm that this is a square matrix. What if it's a trick question? Okay, we only have determinants for square matrices. We have 4 rows and 4 columns, so yes, we do have a square matrix. How are we going to do it? Same way we did it to find the determinant of a 3 by 3. We're going to take any row or any column and expand it, and then take it from there. So let me go ahead, write out what we have. So we have determinant of A equals, let's go ahead and have the notation. So we're going to use the vertical bars. So the first row is given by 0, 1, 0, 1. Next row is, what is it, 2, 4, 7, 6. Third row, 0, 3, 0, 1, 0, 6, 2, 5. Okay, it would have been nice if I make sure I have the elements in the column, but nice didn't happen, so hopefully I don't make a mistake. So now the question is, does it really make a difference which row or column we expand? No, the only thing that will look different is the solution, but if our math is correct, if we don't have a technical difficulty, we will get the same answer. So right here, none of the elements are negative, but we see some zeros and ones. So for me, I'm gonna ask myself, who has the most zeros and ones? So the first row is really nice, zeros and ones. I could work with that. The second row, when I compare it to the top row, no. The third row, same difference, same speech. So if I had to expand the row, I would go with the first one. Okay, but what if I wanted to expand the column? 0, 2, 0, 0. It's like, oh my goodness, we have like a lot of zeros. I'm not gonna look at the rest. I lie, I'm a teacher, so I'm gonna look at the rest. Look at the next column. It's okay, but the first one is nicer. Column number 3, same speech. The first one's nicer. Column number 4, it's okay, but same speech. The first one is nicer. So we are going to go ahead and expand the first column. Okay, now in terms of the size, is it going to be plus this, plus that? You can do some really cool math, or you can just stick with the tic-tac-toe action. So we always start with plus, and then we're going to do sign change. Minus, plus, minus. Okay, so when we expand this column, it's gonna be plus 0 times whatever, minus 2 times whatever, plus 0, same speech, minus 0, same speech. So give me a sec, I'm gonna go ahead start with my special effects. Alright, so special effects are in full effect, so let's do this. So we're gonna take the first entry, so it's gonna be plus 0. So we have the determinant of A equals 0 times the determinant of the leftover entry. So we take that element, cross out the row and column, and then that's going to give us the leftover 3 by 3 matrix. So first row is going to be 4, 7, 6, 3, 0, 1, and 6, 2, 5. Fantastic. Then we're going to have minus the next number, which I really can't see. Bear with me. So minus, cool. So minus 2. Let me go ahead, circle it. So minus 2 times the determinant form of the leftover entry. So let's go ahead, cross out the row and column, and that will give us the 3 by 3 matrix. Row 1 will be 1, 0, 1. Row 2, 3, 0, 1. Row 3, 6, 2, 5. Fantastic. Okay, so then it's gonna be, so we have plus minus, then we have plus the next entry. So plus the next entry, let me go ahead erase this. Fantastic. Let me circle that third element in the column. Cool. So it's going to be plus 0 times the determinant formed by the leftover entries when we cross out the corresponding row and column. So we cross out the row and column, and that will give us the 3 by 3 matrix. So row 1 will be 1 0 1, row 2 4 7 6, row 3 will be 6 2 5. Fantastic. Okay, so we got 3 elements down, so one more to go. The final one will be minus something. So minus, and let me go ahead and unveil this. Cool. So minus that fourth element in the column will give us 0, and then we're going to multiply it by the determinant of the leftover entries when we cross out the row and column. So we cross out the row and column, and that will give us the following 3 by 3 matrix. So first row is 101, second row 476, third row is 301, and we have shown enough work. Okay, for the determinants that are being multiplied by 0, let's just go ahead and cross them out, and we know that that product will give us 0. If you're an overachiever and you want to tell me the determinant of this 3 by 3 matrix, go for it. But for time reasons, no, just set it up. So pretty much what I need to see is that how you expand any row or column, and then the rest, it's up to you how much you want to show yourself. So for that same reason, 0 times this number, because remember, a determinant is just a number. Okay, 0 times the determinant of this, whatever that evaluates to, is still going to be 0, and 0 times this is still going to be 0. So pretty much, if you expanded the first column, the only thing you have to do is take -2 and multiply it by the determinant of this 3 by 3 matrix. If you expanded another row or column, good luck to you. Okay, we'll get the same answer. It doesn't matter how much work you showed. Okay, so this 3 by 3 matrix, let me go ahead, slide my special effect. Cool. So the question is, which row or column should we expand? I don't know, whichever one catches your eye, that one, that's the one that we're gonna do. From these 3 rows and or 3 columns, the one that catches my eye is actually the top row, 101. You can't beat 1 or 0. So let me go ahead, highlight it. Let me see, I think this is too dark. Okay, and then let's go ahead, highlight the sign change. So again, you can do cool math, or you can just play tic-tac-toe. The choice is up to you. We always start with positive, whether we expand a row or column, and then we alternate plus minus plus minus. So let's go ahead and do this. So we have just put an arrow so you know where I am. Cool. Yeah, this is why people use what is it, Surface Pros and iPads, but I don't have none of that, and I don't want to spend my money on it. We can go like semi-analog. All right, let's do this. So we have -2 times the determinant formed by this 3 by 3 matrix. Let me go ahead, put an open parentheses. So if we expand the first row, that's going to give us plus 1 times something minus 0 times something plus 1 times something. So let's go ahead and do this. So the first element is 1, and then we're going to take that 1 and multiply it by the determinant formed by the leftover elements. So remember, we crossed out the row and column, and then that will leave us with the following 2 by 2 matrix. So 0 1 2 5, 0 1 2 5. So we have plus 1. Up next is going to be minus something. So let me go ahead, erase my annotations, and then I'll be able to reveal it. So it's going to be minus the next element in that row that we're expanding is 0. So minus 0 times the determinant of the leftover element. So you can say minor, but it's easier for me to say leftover elements. So we cross out the row and column, and that will give us the 2 by 2 matrix, 3 1, and I think that's a 6. I should read my own writing. 6 -5. I mean 6 5. Yeah, this little tail right here, I thought it was 5. I thought it was with a negative, with the 5. This is why we need to write neatly. Okay, look at this beautiful type stuff. Okay, so we have, what was it, 3 1, and then we have 6 5. Fantastic. So we did plus something, minus something, then we need plus something. So plus, and I can't see the number through my special effect, plus the third element in that row that we're expanding is 1. So it's going to be plus 1 times the determinant formed by the leftover elements when we cross out the row and column. And that's going to give us the 2 by 2 matrix, 3062. 3062. Fantastic. So we have an open parenthesis. Let's go ahead, close the grouping symbol. So we got this. So let's go ahead, take the determinants of the 2 by 2 matrices. First cross product, that will give us 5. Minus the other cross product of 2, and that is being multiplied by 1. Fantastic. Product of 0 and this determinant is still 0, and then that's it. So we have plus 1 times the determinant of this 2 by 2 matrix. The first cross product is 6, and we're going to subtract from it the other cross product, which is 0. Cool. So many grouping symbols. Let me make sure I have everything correctly. All right, so whatever this is, we're supposed to multiply it by -2. So let me put it in parentheses. Maybe I should have used brackets, but it's too late for that. Let's go ahead, clean this up. So we have -2, open parenthesis, times 1. Difference of 5 and 2 is 3. Plus 1. Difference of 6 and 0 is 6. Cool. All right, let's do this. Let's finish off the inside grouping symbol. Product of 1 and 3 is 3. Plus product of 1 and 6 is 6. We got this. I'm crying tears of happiness. I feel like I did a mistake though. Oh, why? Oh, I should be fired. Product of 0 and 5. Oh, is 0. You left me hanging. No, it's okay. I know that you wanted to see if I caught my mistake. Good thing I caught the mistake before I published it. Sorry, I'm not embarrassed. You're embarrassed. Okay, so 0 minus 2 gives us -2. Product of 1 and -2 is -2. All right. Whew. It's okay. It's okay. Sum of -2 and 6 will give us 4. And then product of 4 and -2 is -8. It would have been such a shame after all that work if we had made a mistake. Okay, but this is why I'm gonna show you how to use your calculator, okay, to find the determinant. Okay, so let's go ahead, use our calculator. So remember, pause and rewind as many times need be. Okay, let me go ahead, hit pause, and work on the lighting situation. Okay, so the romantic setting has been canceled. Okay, so let's go ahead, use our calculator to find the determinant. So remember, when you have a take-home assessment, partial credit may or may not be granted. This rule on the side of may not be granted. So it's always nice if you can check your answers. So let's do this. So we want to find the determinant of matrix A. Anytime you want to do something with matrices, you gotta go to the matrix home screen. Okay, so oh, I didn't play with this. It's okay. So we have matrix is not a main key. Maybe this is nicer. Yeah, matrix is not a main key. It's a behind key. Okay, so anytime you need a behind key, you gotta hit second. So second matrix. I think my real finger is better. So second matrix. Okay, and then we want to go ahead, first edit the matrix. Okay, so again, depending on how much you've used the calculator, you may have stuff here, or you may have it blank. Okay, so you want to go ahead, edit matrix, and then you name it whatever you want. I'm not trying to confuse myself, so I'm gonna name it matrix A. So I'm gonna hover over to the right till you're in edit, and then you select whatever matrix name you want. Again, we only have one matrix in this problem, so I'm going to just edit the first one. Let's go ahead, hit enter, and then we're going to put the size. We have established that this is a 4 by 4 matrix, so 4 times 4, and we have a 4 by 4 matrix. Let's go ahead, practice those typing skills. So texting skills 0 1 0 1, and then you can use your arrows to go to the next entry, or you can just hit enter. That's what I do. So 0 enter, 3 enter, 0 enter, 1 enter. I'm not gonna keep saying enter over and over because that gets annoying really quick. Okay, so if you're gonna use a calculator, the toughest thing is for you to make sure that the elements are correct. So it doesn't hurt to confirm that you really did enter the elements. Cool. So let's get out of here. So second, quit. I don't think you have to get out of here, but if you want to see if you edited correctly, well, let me go back to where I was. Okay, it will be a lot easier if you see it right here, and in case you forgot, you can just spit out the matrix. So second matrix, and then we're gonna enter A. You hit enter, and then we should get that 4x4 matrix. Maybe without having that additional space in between, it will be a lot easier to see if you really did enter it correctly, and I think we did. Cool. So now I haven't used my calculator to do this in a long time, so hopefully I do it correctly. So again, anytime you want to do something with the matrix, you got to go to the matrix home screen. So second matrix, I'm gonna guess, because I forget, we're gonna hover over to the math tab. Okay, I guess right. And then we want to select the first option. So DET, it's gonna take the determinant of whatever we ask it to do. So DET, we're gonna hit enter, and then we want to find the determinant of A. So let's go ahead, spit out matrix A. So we're gonna do second matrix, and then look how you saved it. We saved it as A, so we're gonna hit enter, and then we got negative, what was it, -8. So good thing that that you guys helped me with the mistake, else I would have been like really embarrassed. Yeah, and that gives us -8. Ooh, I'm crying tears of happiness. Cool. Fantastic. So that way I know that that I checked it. Okay, so let's go ahead find the next one. Actually no, that's it. I think if you can do this one, then you can use any one. Okay guys, so again, today's agenda was to find the determinant of square matrices. So now in the next video, we are going to take this information to introduce our final technique to solve systems of equations. So sneak peek, we will be using Cramer's rule. Thanks guys.